This is Barry Zalma on insurance. Today we're going to deal with foundations to structures because when dealing with an insurance claim for construction defects, one of the main causes of damage to which structures find themselves, and many of the cases that cause litigation, deal with inadequate foundations. Now, a foundation is the base upon which a structure stands. If a foundation is inadequately engineered, it will not properly hold a structure up and will pose a hazard to the structure, to adjoining structures, and to occupants of the building. Structures are supported by their foundations. Some causes of foundation failure include evaporation. Hot, dry wind and intense heat will often cause soil to shrink beneath the foundation. This settlement may cause cracks to appear throughout the structure. Transpiration. Tree roots may desiccate the soil beneath a home, causing the soil to shrink and the home to settle. Plumbing leaks. Plumbing leaks cause the soil beneath the foundation to consolidate and the foundation to move. Drainage. Improper drainage allows excess moisture to enter the soil surrounding the foundation that can erode or consolidate soils and cause settlement. Inferior foundation construction. The use of insufficient steel and inferior concrete can contribute to movement in the slab since it is not sufficiently stiff to resist cracking. Inferior ground preparation. Soft, low-density soils and or improperly compacted soil beneath a home is often claimed to be a cause of foundation failure. Cut and fill situations should be properly prepared with the advice and counsel of a qualified geotechnical engineer before the soil is considered ready to support a structure. Poor soil conditions. Poor soil and its expansion and or contraction often contributes to foundation failure. And then, of course, for everyone living along the west coast of the United States, earthquakes. Earthquakes. During an earthquake, buildings may be picked up and moved off their foundations by being pushed in the horizontal direction of the quake or vertically perpendicular to the tremor and ceilings. Mitigation of this problem is both simple and inexpensive. Anchor bolts may be used to fix the home to the foundation. The bolts may be placed in newly poured concrete or drilled into an existing foundation. Anchor bolts are then connected to the sill plate with a nut. Some cases involving the failure of a foundation can include Christensen Building Corporation. CBC completed a 42,000 square foot retail store in Roseau, Minnesota for Pameda Inc. Pameda sued, alleging that inadequate compaction and the use of improper fill materials had caused the concrete floor slab to settle and crack, causing substantial damage to the store. The construction defect was refused because of a 2-year from discovery of injury statute of limitations in the state of Minnesota. The use of improper interior fill is not usually discovered by observing a single minor crack in the floor. In the Pamita case, major cracks were discovered in the foundation and slabs and were repaired by Pamita. Pamita waited more than 2 years after discovery of the substantial cracks to file suit. Pamita lost the case because the appearance of significant cracking and settling was initially ignored, and their suit was filed too late to meet the requirements of the 2-year statute of limitations. This is Pamita versus Christensen Building Corp., a 2002 decision of the Eighth Circuit Court of Appeal. The California Supreme Court held that homeowners with homes that have suffered serious damage from cracking caused by ill-designed foundations can sue a construction lender as the joint venturer of the developer on the theory that the lender owed a duty to exercise reasonable care to protect plaintiffs from damages caused by major structural defects. This is Connor versus Great Western Savings and Loan, a 1968 decision of the California Supreme Court. California courts held that causes of action for construction defect accrue when the defects cause damage and belong to the people who own the buildings at the time, rather than to subsequent or prior purchasers. This is Cruci versus S.J. Amoroso, a 2000 decision of the California Court of Appeal. Because the courts in both Pamita and Connor held the plaintiffs lacked standing to sue, neither court faced any question of liability for purely economic damages. In any event, the buildings at issue in both cases had actually suffered major structural damage as a result of construction defects. The courts merely held that strict liability applies when a defective component of a house damages a non-defective component. In Colorado, a home builder is liable for any negligence, not only to the original homeowner but also to any subsequent purchasers. However, this liability is limited to latent defects that a subsequent purchaser would not be able to discover prior to purchase. For example, absence of proper drainage and improper compaction of soil could be considered latent defects if undiscovered prior to purchase. Reversing a summary judgment, the Colorado Supreme Court found that a plaintiff had no knowledge that foundation movement was the result of a design defect until it received a report from an engineer. The court found that it would not be unreasonable to conclude that the settlement problem was linked to a soil problem that was in turn the product of forces and activities beyond the control of the defendants. The Supreme Court concluded that a jury could find liability in the builder and no statute of limitations problem. The foundation settlement problem is not linked, as in other reports, with the unexpected infiltration of water into supporting soils. The Supreme Court assumed that the plaintiff knew of its defect and might have been aware of the possible causes of its defect more than 2 years before bringing the action. The information contained in the reports did not clearly point to the existence of a defect in the improvement because the reports could support conflicting inferences as to the plaintiff's knowledge of the existence of a causally related defect. An issue of material fact was presented and an entry of summary judgment was therefore unwarranted. In issues related to defective foundations are defective shear walls, which are vertical walls in a building that are designed to resist lateral forces. Lateral forces can come from extreme winds or from movement in a floor system due to earth movement or earthquake. Absorption of lateral forces is achieved by attaching shear walls to floors using nails. Factors that alter the allowable load for a shear wall include nail size, nail spacing, and sheathing material, that is, plywood, gypsum board, stucco, or other stiff materials. The various building codes list allowable loads for shear walls with values intended to protect against lateral loading. These ratings are based on testing tight as installed systems on rigid floors. It is important to remember, when looking at the allowable loads, that neither wood shrinkage nor the wood flexibility are considered when testing or rating shear walls. Wood shrinkage results in decreased shear wall performance because it allows connections to loosen or wood to split. The Uniform Building Code states the following on the topic of wood shrinkage. Consideration shall be given in design to the public effect of cross-grain dimensional changes considered vertically which may occur in lumber fabricated in a green condition. Engineers estimate that the strength of a shear wall can be reduced by up to 30% by wood shrinkage. The Engineered Wood Association found in cyclic tests of 8 shear walls constructed with green lumber that there was not a significant loss of strength, but found that stiffness of the shear wall was reduced. Manufactured wood floor joists are a great improvement for the shrinkage problem. These manufactured joists can provide consistent quality, dimensional stability, and high strength. It is important to remember, however, that if these manufactured products are not protected during storage and shipping, they can absorb moisture and swell in the same way as other lumber. Kiln-dried wood is an option for working with specified moisture content. However, this wood is only dry as it leaves the factory. Use of automatic take-up devices, which use internal ratchet devices or the jack-screw principle, developed to work with prefabricated shear walls, hold-downs, or threaded rod systems, can compensate for shrinkage as the building dries and settles. The IBC offers 3 basic approaches to designing shear walls with openings. 1. Traditional or segmented design. Each shear wall meets applicable height-to-width ratio, and hold-downs are placed at the ends of each such segment. 2. Force transfer around openings. Hold-downs are placed at ends of the shear wall with openings reinforced by strapping or framing with the height-to-width ratio requirement governed by pure wall height. Or 3. Perforated shear wall design, or no force transfer around openings. Hold-downs only at the ends of the shear wall, with openings accounted for by empirical factor not requiring strapping around the openings, with the height-to-width ratio defined by the full weight wall height segments and sill plate uplift requirements. Typical defects with shear walls include 1. Tearing of shear wall element, and or 2. Shear element detached from lath or framing as a result of an earthquake, landslide, mud flow, or expansive soils. Failure of shear walls can be caused by any of the following: improper anchorage of foundations to walls, improper nailing of shear element, including using box nails instead of common nails, driving nails too close to the edge of the plywood panel, spacing nails too far apart, fracturing the surface of the plywood with the nail's head, overdriven nails, or nailing at panel edges or at oblique angles. Also, lack of sufficient bracing, failure of hold downs, or inadequate shear strength in panels installed. The proper measure of damages due to the defective design of a building is the cost to remedy the defect unless such amount is grossly and unfairly out of proportion to the good to be attained by fixing the building. This video was adapted from my book, Construction Defects and Insurance, Volume 2, which is the second part of an 8-part treatise on construction defects and insurance, and is available from Amazon.com as both a Kindle book and as a paperback. If you found this video to be interesting or useful to you or your colleagues, please pass it on. It's free. And please also subscribe to my YouTube channel, my Rumble channel, my blog, and my Substack publications so that you can be made aware of future blog postings and future videos. Thank you for your attention.